Okay, so sorry for that rather abrupt interruption. Okay, so we were discussing restriction digests. So we have multiple copies of these chromosome 1s, multiple copies of the chromosome 2, all the way down to the multiple copies of chromosome X. What we are now going to do is what is known as a partial restriction digest. And this is a really important concept that I need to explain in some detail. So let's say we have our chromosome 1 here. So let's say this is chromosome 1. Okay, and we are going to unleash our restriction enzyme onto chromosome 1. Now, there are potentially absolutely loads of these recognition sites that the restriction enzyme will recognize all the way along the length of chromosome 1. So let's say these are all recognition sites that the restriction enzyme will recognize. So let me color them in. Okay, now the concept of a partial restriction digest is that you're not going to cut at absolutely every single one of them. So what we could do, we could put absolutely loads of restriction enzymes onto our DNA, enough that absolutely every single recognition sequence will be cut, basically. And then what will happen is that all of our chromosome 1s will be fragmented into all of these pieces. So let me show you. Oh, and you'll get these overhangs, by the way, so let me put in the overhangs. Right, so this one needs to have this overhang this way, and then you'll get this piece here, and this one here, and this one here, and this one here. So you could put in a high enough concentration of restriction endonuclease that you cut at absolutely every single recognition site, basically. So all of the chromosome 1s are cut into all of these fragments. Alternatively, you could put in a lower concentration of restriction endonuclease. So this is at a high concentration of restriction endonuclease that we get this. So every single recognition site is going to be cut at this high concentration of restriction endonuclease. That's what's known as a full restriction digest. So every recognition site is cut, basically. Okay. So a full restriction digest is what that is. Full restriction digest. Now, why do we not want to do that? You might think that's a good idea. We want to cut up our DNA into loads of little pieces, and then what we'll do is we'll take all these fragments and sequence them. And you could indeed do that. The problem is, how do you then reconstruct it? How do you know which fragment, what order the fragments go in, basically? How do you know that this fragment should be followed by this fragment? So say we sequence this fragment and we sequence this fragment. Then what? How do you know that they should be next to each other? You don't, is the reality. You might say, but they've got these overhangs. But the overhang here will be exactly the same as the overhang here, will be exactly the same as the overhang here. So basically, you could go away, you could cut all your chromosome 1, your chromosome 2, your chromosome 3, all the way up to chromosome X. You could cut them up as much as possible. You could perform a full restriction digest. You could then sequence all of the fragments, and you wouldn't be able to put it back together. Think about it. I urge you to think about it. How would you do this? Would you be able to put them back together? You wouldn't. If you can come up with a way of doing it, brilliant. But I can't come up with a way of doing that. So instead, what we do is something cleverer. We do what's known as a partial restriction digest. And this is why it's necessary to have multiple copies of each chromosome. Okay, so instead of putting so much restriction endonuclease on that there is enough to cut every single recognition site in every single one of the chromosomes, instead what we do is we put not enough on so that only some of the recognition sites get cut. So let me now show you this, what a partial restriction digest might do to this chromosome 1. Okay, so a partial restriction digest might look more like this. Okay, so let's say this one is our first fragment. So we didn't cut this first restriction site, we didn't cut this second restriction site, but we cut the third one, let's say. Okay, so this is our first fragment we've got. Okay, then let's say we cut that third one, so that we've now got this second fragment here. Okay, so the overhang needs to go there. Okay, and then let's say we didn't cut this next one here, so this one's here, and we cut this next one down here. Okay, so we cut that one there, and then the final fragment, let's say we didn't cut this next one here, so here's that overhang, and then you'll have this final restriction site that hasn't been cut here. So you've only cut some of the restriction sites. Now you might say, well, how are you any better off? If we could sequence all of these fragments potentially again, but how are you going to put them back together? Well, this is the genius part. This is why we need multiple chromosome 1s, because if we do this partial restriction digest on all those different chromosome 1s, each chromosome 1 will potentially be cut in a different way. So let's show another way that we could have cut this up. So we've got multiple chromosome 1s. So let's say this is the way one of these chromosome 1s was cut up. Now let's show the way another one was cut up. So let's say this other one did get cut on this first restriction site. So it formed this fragment here. And then let's say the next fragment is here. And let's say the second restriction site then didn't get cut. Okay. And let's say this third restriction site didn't get cut. Okay, and then finally this fourth one did get cut, so there's that one being cut. And then this, let's say the other two just weren't cut at all, so it has a fragment that looks like this. So which ones weren't cut? This one wasn't cut here, so that should be there. Okay, this one wasn't cut, so that should be there. This one was cut, and then these two weren't cut here. Okay, so let me colour those in. Right, so why does this help you? Because what you can now do is sequence all of these fragments, basically. And basically, if you find the sequence of this fragment, and 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 the sequence of this fragment, you can now, I claim you can now put the thing together. Because if we look at this, the sequence of this fragment, there'll be a great big overlap with the sequence of this fragment, because all of this bit here overlaps with all of this bit. So you'll get the code for this one, you'll get the sequence of organic bases for this one, you'll see this massive great overlap. So you'll say, okay, this one must have been joined to this one. So you can say, right, take the code of that one, then add on the code of this one, but this one extends beyond where this one ended, so you can now add the extra organic bases that are on this one that aren't on this one onto there, and now again this overlaps with this one here, so you can then say, okay, put this one on top of here, but this one extends beyond what this did. And then what you'll say is, okay, this one now overlaps with that one, so you can keep working down, basically. You've got this overlap in the sequences of the different fragments, and therefore what you can do is you can piece it together. You can say this bit overlaps with this bit, so these two fragments must follow one another, and then you can build it up like that, and that gives you a way of putting together the whole sequence of the chromosome 1. Now you'll do this for all 23 chromosomes, and you can therefore build up a picture of the sequence of the overall chromosome. This is what's known, this sort of technique of putting the sequence of the different fragments together, overlapping them, and realizing that this one must follow that one, etc. That concept is known as restriction mapping. Okay. Restriction mapping. So you can therefore sequence the genetic code of a much larger piece of DNA because you can sequence the code of the fragments, and then you can piece it together, back together with restriction mapping. Okay, right. So we'll continue our discussion in the next video.